This is the last section of this chapter. And we're kind of going back to talking about linear and absolute value, because remember we said in the past that absolute value is just another type of linear equation, but we're going to get into inequalities today. So inequalities would be when you have less than or greater than signs, things like that. And we're going to kind of go back and still also talk about like intersections and unions of things. So remember, that's when things either overlap or we look to see what do they only have in common versus what are all the pieces that could belong in the two sets that they were given. So we'll talk a little bit about that, and we'll get a little bit more into the notation, interval notation, and how to write your solutions in the interval notation that they're asking for. So more than just saying x equals this, we want to be able to say it could be in between any of these two values, and we'll talk about the differences in some of the brackets that you'll see and when do you use a regular parentheses versus a harder bracket and stuff like that. So this kind of first chunk here talks about the interval notation and when you use what. So the first one is called an open interval. That's when you have parentheses on both sides of the numbers. And they're using A and B because A and B could represent any of the numbers that you could possibly have for solutions. So it's talking about that A, B with the parentheses represents the set of real numbers between, but it doesn't include A or B. So this would be when you have just like a less than or a greater than sign. No equal sign is included here. So it could be up to a certain number, but it can't actually equal that number, or it could be smaller than that number, but again, it cannot ever equal the number because it doesn't have that equal sign in the symbol. For example, if I had something like on a number line, so let's just say that's what I had, and I had 3 and 5 as my kind of boundaries, they would have parentheses like that on the number line, but then if I were to write it in notation form, it would be 3, 5. And so how I would read that is my solutions to the problem could be anywhere between 3 and 5, but they can't equal 3 and they can't equal 5. So it could be as close to 3 as possible. So it could be 3.000000000 forever, and then maybe a 1 is attached at the very end of that number. And same with like, it could be as close to 5 as possible. So like 4.9999999 forever and ever. But if it equals 5 or it equals 3, it doesn't count. It's not included. Now, closed interval would be similar to what we just saw up there, except it does include the numbers that are inside. And so instead of having parentheses, you're going to see kind of the harder brackets, like the more squarish ones, not your regular parentheses. But so that means you're talking about the numbers in between, but also it includes the numbers that you have in the set. So this would be when you do have the equal sign attached to your less than or greater than sign. So another example of that, if again I'm on the number line, and this time I'll be a little bit more vague, but let's say I have 0 and 7. This time you'd have those brackets, and we would write it like this. So my solution is between 0 and 7, and it can equal 0, or it could equal 7. But again, we can't go below 0, we can't go above 7, just like on the last one, we can't go below 3, we can't go above 5. We're kind of showing that it's got to be stuck between those two numbers. Now, sometimes though, you'll have just one number as a solution, and then like anything greater than or less than that number works. And so sometimes we'll have to use the symbol for infinity when we're talking about that anything above this point would work. And so in an infinite interval, you could have kind of a combination. It could be either closed or it could be open. So you could have parentheses or you could have hard brackets. When you have infinity being represented, it's always going to have a parenthesis by it. So if you notice on both of these here, like the notation right here and right here, the top one has parentheses A, comma infinity, parentheses, and then the bottom one has parentheses negative infinity, and then B with the hard bracket. You'll notice on both of those, though, by the infinity symbol, there's a parenthesis. And that's just because infinity is unlimited. So it would keep going and going and going and going. The numbers would continue to get bigger or continue to get smaller. So we can't put a hard bracket on that because we don't actually have a number that represents infinity, because infinity goes forever. So we always have a parenthesis with infinity to represent it would continue to go beyond the highest point that we could get to. So even if we try to find the highest number there ever was in the world, we die, someone has to take it over and they have to continue to find the highest number there ever was in the world. It's never going to stop. So if I'm thinking about this on like a number line, for this first one, you would have just like one value is what works. So like 3 maybe, and we'd have parentheses around 3, and then it would continue to go forever towards the right. And so I would write that as 3, comma, positive infinity, because it would continue to go to the right forever, which is always positive on the number line. And then for the other example, let's just say I had my solution at -1. This time I'm going to show you with the hard bracket, and then also I'm going to have it go to the left to show that it's going towards negative infinity. And so we would write that as negative infinity, comma, -1 with the hard square bracket. So on that top one, we have maybe seen it before where it would say like anything greater than 3 would work for solutions. So you would say x is greater than 3. And that's probably what you're more used to seeing, is something like that. And same over here, it would be this time though, anything less than or equal to -1. So just kind of giving you that context of that's where the inequality sign is coming from, and that's why we notate it the way we do. The one without the equal sign had a parenthesis by the 3. The bottom one has the equal sign, so that's why it's a hard bracket by -1. All right, so what we're going to do first is just practice graphing these before we even get into solving. And so they want us to graph and write in set builder notation. And so they're giving us the solution set. So we have a parenthesis by 1, and then 5.6 has the hard bracket. And I have a number line already drawn for you. So I would just first start by like numbering your number line here. And it doesn't really matter where you start it. So even if I just say, okay, this is -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. And you don't have to be as descriptive on these number lines, but just give me an idea of where your numbers are at. Show me where your solutions would be. And then we're going to graph these. So at 1, it's not including 1. So we could get as close to 1 as possible. And so I'm going to put a parenthesis around 1. And then I have to figure out about where 5.6 is. Now, you're going to have to estimate on that because we are on a number line. So 5.6 would be a little over halfway. And this time you're going to have a hard bracket. In the past, when you guys were expected to graph things like this is when you maybe were asked, like, should you have an open circle or a closed circle around the numbers? It's like that idea, except instead of having open circles, we have a parenthesis. And instead of having closed circles, we have the harder bracket. So it's kind of the same idea as when you were solving those inequalities. We're just being a little bit more picky about our notation. Now that's graphing on a number line. They also talk about set builder notation. So you'll have seen up here on all these examples, they showed you like this is the set builder notation that they were talking about. So let's just write that out for our answer here. So to write set builder notation, you're always going to start with kind of those squiggly brackets, and then X with the line after it. And that's just kind of saying, hey, this is what's going on with my X. And then we're going to write out our numbers. But then that's when I was talking about like open circle versus closed circle. So we know that the lower limit is 1, and it's going everything to the right of 1. So that would be greater than 1. Now you have to think about this with your symbol. So there's going to be an X in the middle. If I want to write greater than 1, I have to have my inequality sign open up to the X. So think about those, mouths as like alligator mouths, and it's always eating the bigger one. So we want it to be greater than 1, not equal to 1 though, because we had a parenthesis. And then it goes up to 5.6, but it can't go beyond that. And it does have the hard bracket, which means it's equal. So we're going to say less than or equal to 5.6. And then you just close it with those squiggly brackets again. Okay, you guys try the second one. Okay, so there wasn't a number line on this one for you. You had to draw your own, so I just gave you an example. Yours might look different than mine, and that's fine. At 7, we're going to have our hard bracket, and it's going this way. It's going to the right. Because of my notation, it says it's from 7 to positive infinity, which means everything to the right. And then over here, how did you guys write that? X is what? Yeah, greater than or equal to 7. Because that shows what we did on our number line. We had 7 included because of our hard bracket, and it went forever to the right, so it's always going to be greater than 7. Okay, now we're going to talk about how do you find either the intersection or the union when you have more than one of these types of solution sets given to you. So instead of just focusing on one, if they give me 2, I might need to figure out where is the union of them and where's the intersection of them. So in order to do that, I would first graph each interval on your number line because it sometimes can help if you can visually see what's going on the number line to figure out where do they cross versus what's everything that's included in our problem here. To find the intersection, you take the portion of the number line that the two graphs have in common. So remember, the intersection would be like when we had our sets of numbers that we've done this before, you would only look for the numbers that they shared, and that would be your intersection. To find the union, you take the portion of the number line that represents the total collection of the two together. So that would be like when we wrote all the numbers that we saw in both of our sets of numbers. So for example, I want to find the intersection and the union of, my first one there is 5 and 9, hard brackets on both ends there. And the other one is 6 and 15. Those both have the soft parentheses. Okay, so I'm going to first start by graphing both of these. And I have a number line, and I need it to go from 5 to 15. So I'm going to start by numbering my number line. Okay, for the first one, it's contained between 5 and 9 hard brackets on both ends. So 5 is the lower end, 9 is the upper end. For the other one, it's between 6 and 15, parentheses for these ones. So 6 gets a parenthesis, and 15 gets a parenthesis. Now I want to figure out what's my intersection and what's my union. Remember, intersection is only what they have in common. So kind of think about if they were to overlap, where would they overlap at? And it might even help, like I have mine kind of color-coded up here, but if I were to draw lines connecting my brackets or my parentheses here, where do they overlap at? Between what numbers? 6, 7, 8, 9. So right here. Well, that's not a very good color, but right here is where they kind of overlap. Okay, so the intersection is going to be between those numbers. So we're going to start it at 6, but it's at a parenthesis on 6. So we have to keep that notation the same. And then it goes up to 9, and 9 has what? Parenthesis or bracket? Bracket. So that's your intersection. That's where they overlap in the middle. Now the union would be, how do we write the notation that encompasses everything in the graph? So like what's the lowest bound up to the highest bound? So in this case, the lowest is what number? 5. And is it parentheses or bracket? Bracket. And then it goes up to, good, 15 parentheses. Okay, you guys do the next one. You're the second kid I've had that happen today in here.
Actually?
Yeah.
Wait, what happened?
Contact like fell out.
Like he was holding his tooth. I was like, no way.
That would be scary. Okay, so I've got my number line created here. I'm going to start plotting those sets of numbers. All right, what did you guys say for the intersection? Good, I agree. Again, if you're looking at your, like even if you shade a little bit on the number line there, or if you have like different colors like I'm doing, like colored pens or highlighters even, that would help too. You can see kind of right here in the middle, between those two parentheses is 0 and 1. Parentheses on both ends there. What about the union? Good. Everyone agree? Okay. So now that we know how to do that and we know how to put them on the graph and be able to read the notation, now we're going to start solving equations and then still finish off with writing it in the correct notation with like parentheses or brackets and then putting it on the number line. So going to just a regular linear equation. I want to solve this. What would you guys do first? So I have negative 3x less than 5 minus 2 would be 3. Now what? What happens to our inequality sign when we divide by negative? It flips. So we don't want to forget that. So this is going to become x is greater than what? Negative 1. Okay, so this doesn't have two bounds on it like the last ones did, where you had like two specific numbers. We just have one. We know that x has to be greater than negative 1. So I'm going to come over here to my number line now, and I'm going to start by just putting, I'll put negative 1 here, 0, 1, 2, 3, and do I do a parenthesis or a bracket at negative 1? Parenthesis, because our inequality does not have an equal sign. And then it goes forever in what direction? To the right, because I want everything bigger than negative 1. So it's going to kind of draw that on my line. So how would I write that in notation? Yeah, negative 1, comma, infinity, and parentheses on both ends. Okay, if you go to the top of the next page, we're going to talk about some special cases now. All right, so let's start out by solving this here. What would you guys do first? Distribute. Okay, 3x plus 12 is greater than 3x plus 1. What would you do now? Or is there something that maybe you're noticing about the two sides of the equation? The 3x's are going to cancel out eventually. If I do it right now, or even if I wait, if I try to put my numbers together, eventually these 3x's on both sides are going to cross each other off because I'm going to have to subtract a 3x at some point to get it over to the other side. It's going to disappear. So I have left 12 greater than 1. I have no more x. So look at what's left. Is that a true statement? Is 12 bigger than 1? Yeah, 12 is bigger than 1. Yes. So 12 is bigger than 1. This is true. So if you're left with a statement that's true, because in the past we have like equal signs here, and anytime that this happened, we would say no solution because the x's cancel, but what I'm left with is not the same. In this case, it's a true statement because there's no more an equal sign, there's a greater than sign now, which means any number works. So how I would write that is negative infinity to positive infinity. Now, if you look at the next one, we're going to start out the same way. We would distribute the 5. And you might notice again, okay, those 5x's are on both sides. They're going to cancel. And I'm left with 20 greater than 31. Is that true? No, that time it's false. So if it's not true, there's no solution. Or in the past we've talked about they would maybe write it like a 0 with a slash through it. That's just another way you could write no solution without having to write out the words if you didn't want to. So if what you're left with is true, then your answer is always negative infinity to positive infinity. If what you're left with is not true, it's no solution. Okay? Questions on those special cases like that? Okay. We're going to get now into a compound inequality. This is when you have double inequality signs in your problem and you have to split it into the 2 separate equations and solve both of them. So for the first side, I'm going to set up this one. 1 is less than or equal to 2x plus 3. And then for the other side, we take the 2x plus 3 again, but we say it's less than 11. Okay, let's start with the left-hand side. I'm going to subtract 3. So I have negative 2 is less than or equal to 2x. What would we do next? I would divide just the positive 2 because I want to get rid of it from the x. And so that would be negative 1 is less than or equal to x, or if you flip that around, x is greater than or equal to negative 1. Okay, let's go to the other side now. I would start by subtracting 3. What's 11 minus 3? So I have 2x is less than 8. Then we divide by 2 again, and we get x is less than 4. Okay, so now let's go to our number line here. Do I have parentheses or a bracket at negative 1? Bracket, because it does have the equal sign. And which way would we be shading if we followed the sign? To the right. So we would be going this way. Okay, now at the 4, is it a parenthesis or a bracket? Parenthesis, and which way do we shade? To the left. So they're going to overlap there in the middle. So then if I want to write this out as one single notation, I would say bracket negative 1, comma 4, parenthesis. We want to keep using that notation that we've been learning about. All right, last scenario we need to talk about is absolute value. And this is related to linear because absolute value graphs are V's. They look like lines still, but they just have a V shape to them. But the 2 parts are still linear. And when we solved absolute value equations, we had to set it up two different ways. We had to set it equal to the positive answer and then to the negative answer. So we're still going to do that with these inequalities. When you have inequalities with absolute values, same situation has to happen. You have to set up two separate ones. You'll have to change the sign, but you'll also have to change the sign of, or the direction of your inequality sign as well. That's like an extra change that we have to make here. The same rules apply for that what we've been doing with our like notation, putting on a number line, and all of that stuff. Okay, so let's do this first one together. And I do have that little reminder there. You're going to switch the order of the inequality as well, so we want to make sure that we do that. So for the first one, you're just going to bring everything down as it looks. So 18 less than 6 minus 3x. We just bring everything down, and then we solve. Let's just go ahead and solve this here. What would we do first? Minus 6. So we have 12 less than, we bring down the negative 3x, then what? What happens when we do that? Flip our sign. So negative 4, this sign flips the other direction, and we have x. Or I'm going to flip everything around so I can read it a little bit better. X is going to be less than negative 4. Okay? Now let's go to the other side of the equation. So to do the second one, you have to switch the sign of 18. So 18 is going to become negative, and the sign of the inequality has to flip as well. So it's going to say negative 18. We're going to flip that sign, so it's now opening up towards the negative 18, and then still bring down the 6 minus 3x. Solving is going to be the same thing. We're going to subtract 6, and we're going to divide by that negative 3, but our numbers just might be a little bit different now. So if I subtract 6, negative 18 minus 6 is going to be negative 24. Then if I divide by negative 3, what do I get? 8. My sign has to flip because I divided by a negative, and x, or x is greater than 8. If you can read it backwards, you don't have to flip it back like I'm doing. I just know for some students it's confusing to read it backwards. So it's helpful if you have x first. So now let's put this on the number line. We need a negative 4 and we need an 8. I don't know if we have enough space for all that, so it doesn't really matter. I'm just going to put negative 4 here, and I'm going to say 8's over here. Do I have parentheses or brackets at these numbers? Parentheses at both of them? Okay, so let's think about the negative 4, because I got to decide which way my parenthesis faces here. Am I going to be shading to the left of negative 4 or to the right of negative 4? I got 2 votes for the left and 1 vote for the right. Well, it's less than negative 4. So if negative 4 is right there, where's less than negative 4? To the left. So I want my parenthesis to open this way because I want to shade to the left. The other side says x is greater than 8. So what's that going to look like? To the right. So my parenthesis needs to open up this way. Okay, we haven't seen one of these yet in class where they're kind of going in opposite directions. All the ones that we saw earlier, they were going towards each other. So in this case, I need to write this out as it's going towards negative infinity forever. So parentheses, negative infinity, negative 4. And then because they're kind of doing opposite things, we have to use that symbol for that union. And how would I write the other side? 8, infinity. If they're going towards each other, then I would just write it as negative 4, 8. And they would just have parentheses going the other way, and the shading would be going towards each other, like we saw in that last example. Okay, last one. I'll get us started here. We're going to bring everything down as is. I'm going to subtract 8, such 3x is less than 7. Divide by 3. I'm going to leave it as a fraction, 7/3. X is less than that. What should I write for the second equation?
Opposite side of greater plus greater than negative.
Good. Subtract 8 again. This time, though, it's now 3x is greater than negative 23. We divide by 3. Again, I'm just going to leave that as a fraction. Okay, then down here, I got to place those numbers somewhere on the line. And again, I don't really care where you guys put them. I just need to see them on the number line and then see the correct notation. The negative 23 over 3 has to go somewhere on the left. So I'm just going to put it right here. And then the 7/3 has to come over here on the right somewhere. Okay, for the negative 23 over 3, it's going to be a parenthesis, but which way am I shading? To the right, because it's greater than that. So my parenthesis needs to open this way, and I want to shade to the right. How about for the 7/3? Shade to the left. So they overlap in the middle. So how should I write this out? Just like that. Questions? Oops. Okay.